Okay. So if you will ask me to solve all the questions, I will solve all the questions. No problem for me.
Yeah, that's fine.
So the next is integration by partial fractions. So partial
Mm-hmm.
fractions is simply we can integrate these type of uh, fractions, uh, what do we say, rational functions. If we have rational functions like this, then we can integrate by resolving into partial fractions. So you know about how to resolve in partial fractions.
Yes, you go like you make A over one of the times and then plus B over a different time, right? And then you compare the coefficients.
Yes. So because this is
Mm.
a fraction, you need to divide it into two or as many as number of fractions depending upon the factors of the denominator. How many factors are there in the denominator? There are two
Two, right?
factors, two linear factors. Now in this example, we have linear factors in denominator.
Mm-hmm.
If we
Yeah,
have linear factors in the denominator, we can resolve it like we will say, suppose that x minus 5 over the given fraction is equal to sum of two fractions, a over one factor plus b over the other factor. So
yeah.
we call it equation 1.
Mm-hmm.
And now our job is to find a and b from here. What is a and
Mm-hmm.
what is b? This is actually the reverse process of adding two fractions. We add two fractions by taking LCM, then we can go in reverse by resolving into partial fractions. This is the method. So what is the
Mm-hmm.
next step after supposing that it is equal to sum of two fractions like this? Next step is to multiply the denominator both sides. Multiply this
Yeah.
equation 1 by the whole of the denominator. So it will
Mm-hmm.
become x minus 5 on the left hand side, and a times x plus 1 will be cancelled, x minus 2 will be left with a. And
Yeah.
if we multiply this with this second term, so x minus 2 will be cancelled and x plus 1 will be multiplied with b. Is it clear?
Mm-hmm. Yeah, yeah.
Now, from equation 2, if you want to find a, you need to put the value of x equal to, a negative 1. If we put
Mm-hmm.
x equal
Yeah.
to negative 1, what will happen? This bracket will be cancelled out and this will be become 0, this second term, because
Yeah.
minus 1 plus 1 will be 0. When we put x
Mm-hmm.
equal to minus 1 in equation 2, we will have this b times
Yeah.
minus 1 plus 1. So this term will become 0 and
Mm-hmm.
a will be determined from here. Negative
Yeah.
3 times a. So a will be equal to
Two.
2. Similarly,
Mm-hmm.
if we put x equal to 2 here, what will happen? A will be cancelled out and we will get the value of b. So
Mm-hmm.
now put x equal to 2 in equation 2 again. So 2 minus 5 equals to a times 2 minus 2 plus b times 2 plus 1. So this term will be cancelled out and negative 3 equals to 3b. So b, we have got b equal to 1. So a is 2 and
Minus
b
one, yeah.
is, yeah, a is 2 and b is 1. So we will put a is 2 and b is 1 in the first equation.
My,
So 2 upon, it will become 2 upon x
mm-hmm.
plus 1 and plus 1 upon x minus 2. So we have resolved it into partial fractions. After resolving into partial fractions, we
Yeah.
just need to integrate 2 upon x plus 1, 1 upon x minus 2. So our integral will be
Okay, okay.
equal to 2 upon x minus 1 plus 1 upon x minus 2. After resolving into partial fractions, let's suppose that the integral given was equal to I. So this is I. So I is equal to now, after putting partial frictions, we are here. Now see, integration is easy for you. Just you need to know how to resolve into frictions, partial frictions. Now, how will you integrate?
Hmm.
How will we, how can we integrate? We will integrate separately each of the
Yeah.
terms.
Um. Yeah.
2 can be taken
And then
outside, integration
that.
of this.
Oh, you can just
I cannot,
integrate directly, right?
how to integrate
Or like
this?
because the derivative is present at the
Yeah,
top, is it not?
yeah.
Hmm.
So it is, we usually use these type of integrations in these questions. When the derivative of the denominator
Yeah.
function is present in the numerator, then its integration is log of the absolute of the denominator function. This. So it is log
Yeah.
of x minus 2 plus similarly its derivative is also 1. So it is log of x minus
Yeah.
2 plus c. Oh, this
It's
was
x
x.
minus
This
first.
first one is x plus
X
1.
minus one. Oh,
First
plus
one
one.
is
Yeah.
x plus 1. Okay. First one is x
Hmm.
plus 1. This is x plus 1. X plus
Yeah.
1 and x minus 2. We can express this in single logarithmic function because there are two. It doesn't look nice. So in order to uh, have a really nice expression in the end, we need to express in single logarithmic function. How can we do it? We can take 2 to the power using power rule, right?
Yeah. And then for addition, do you
For
multiply
addition,
the two inside
yeah,
one?
you you multiply this with x minus 2. This
Mhm.
is now in single logarithmic function. We
Yeah.
have used power rule of logarithm and product rule of
Mhm.
logarithm. So
Yeah.
I removed the absolute sign from in the first term here because square will make it
Well,
positive. So you need to don't need to put absolute sign, right? But
yeah.
absolute sign will be given in the second factor like this. So this is the answer of this question.
Yeah.
Okay.
Mhm.
So
Yeah. The hard part
similarly,
is when you have like refract that kind of thing,
when you
like
have
top heavy. That's when it gets wacky.
what is the difficult? What do you think it is difficult?
What top heavy, right? Because then you have to like
Yeah.
do some division and that kind of stuff. Or how do you
Yeah.
separate top heavy?
Yeah. This question, what is the numerator? What is the degree of the numerator?
They're both squared,
Both are
so
squared.
degree two.
So for partial
Hmm.
frictions, as you said, degree of the denominator should be greater.
Hmm.
So
Yeah.
for partial frictions, degree of for applying the partial frictions, degree of numerator should be less than degree of denominator, right? This is the rule. You cannot apply
Hmm.
partial frictions if
Yeah.
degree of numerator is greater than the degree of denominator.
Hmm.
So what happens if the
Yeah.
degree of numerator is more than the degree of denominator? Then you apply the division, more or equal. So in this particular case, you can divide or you can also apply the partial fractions in this case as well. How can we do it?
Uh,
Without division. We can do it with division, and we can also do it without division. You see, the degree is same.
Yeah, it's the same. So,
So let me tell you a method which you can directly apply.
mhm.
Let, okay, this can be expressed as like this. Factor the denominator. What is common? Nothing is common. So what are the factors? 3x minus 2 times 3x plus 2. These are the two factors, right?
Oh, I see. Okay.
Yeah, you will apply this formula a square minus b square. So 9x
Hmm.
square can be written as 3x squared and b square can be written as 2 squared,
Hmm.
right? So this will
Yeah.
be 3x minus 2 and 3x plus 2. These are the factors. Now we will suppose that this is equal to 1 plus a upon the first factor plus b upon the second factor. Let's say
Is it
this is
always one?
equation 1.
Sorry.
y1, y1.
Yeah, why
In
one? Is it
pre
because it's the greater?
bec-
Or
because the degree of numerator and denominator both is same. You can apply this method if degree of numerator is equal to the degree of denominator. Degree of
Mhm,
numerator is equal to degree of numerator. This is only for this case when both of them have same degree.
mhm, mhm,
If numerator is higher in degree, then you need to divide. That is must. If
mhm,
both have
mhm.
same degree, you can just add one. Yeah.
Okay.
And it will solve your problem. So what is the next step? You find second equation. How you find second equation? You multiply the denominator both sides in order to make it this equation simpler. So if we multiply the left hand side, only numerator will be left 9x squared minus 3x plus 2. And on the right hand side, if we multiply these two brackets with 1, you will have 3x minus 2 times 3x plus 2.
Mhm,
And if we multiply this with this second term, 3x minus 2 will be cancelled. So 3x plus 2 will be left. If we multiply
mhm.
this with the third term, then 3x plus 2 will be cancelled and left will be 3x minus 2. This is two equation. Is it clear?
Yeah. Yeah, yeah.
Now again the
Um,
same procedure. We have to find A or B. You need to make substitutions. Put the value of x. Put x equal to what? So that we get any one of the value A or B. What should we
do you
put?
not first that equation and like minus it from the one? Sorry, the one.
What
Is
you
it
will
not better
put?
to? You can put negative 2/3.
Yes. Put negative 2 over 3 in everything. So this term will be
Yeah.
cancelled out, right? And this term will also
Yeah.
be cancelled out because this will become 0. This bracket will become 0 when we put negative 3 upon 2. So just put negative 3 upon 2, negative 2 upon 3 to left hand side. Negative 2 upon 3 plus 2. And first and second term, just calculate this part.
The first part is -4 minus, hang on, -3. Okay, so it's the left hand side is -4 altogether.
Are you
Oh,
sure?
times 9. Oh, no, 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 I'm not sure. No, I'm not sure.
Sure.
Um,
It is 8. It is 8.
I'll believe that. Oh yeah, because I
It is
forgot to put in the bracket. Yeah,
it is simple. It is simple, very simple. 9
yeah,
times 4 over 9 plus 2 plus 2. So 9 will be cancelled and we will be having 4 here and 2 here and 2 here. So it is 8.
yeah.
So B is -2.
Hmm.
Similarly, now we will put x equal to, so that this will become 0.
Yeah.
X is equal, ah, so we will put x
So,
equal to 2 over 3,
yeah,
right? So let's put
yeah,
x equal to 2 over 3 now. So the left hand side will be 9x square minus 3x. So 9x square minus 3x plus 2
hmm,
equal to, again, first term will be cancelled out and the last term will be cancelled out. So we will be left
yeah,
with only this term, a times 3 times 2 over 3 plus 2. Okay.
hmm,
So this will be
yeah.
4 minus 2 plus 2. So this is 4 on this side and
And
4
4 side.
4a on the right side.
Hmm.
So a is
Okay.
equal to 1. A is 1. So a is 1, b is -2. A is 1, b
Hmm.
is -2. So we will put everything in equation 1. Put a is
Yeah.
1 and b is -2 in equation 1. And equation
Hmm.
1 was our initial supposition, this equation. So 9x square minus 3x plus 2. 9x square minus 3x plus 2 divided by 3x minus 2, 3x plus 2 equal to 1 plus a upon 1 upon 3x minus 2 plus b upon 3x plus 2. This will
Hmm.
be equation 1. After putting
Yeah.
in equation 1, let's check it again. 3x minus 2 upon 3x plus 2. Oh, yeah, that's fine. That is absolutely fine. So we have resolved into partial fractions directly without division.
Hmm.
These are the partial fractions. If you do it with
Yeah.
division, then the result will be same.
Hmm. Okay. Um, and then there was just another thing, which is like when in the bottom you have a squared, like with one of your denominators is squared. What do you do about that? Like if
Yeah,
you have a,
when denominator has quadratic factors,
hmm,
you are asking that the denominator have quadratic factors which cannot be reduced to linear, like x square plus 2 times x square plus 4, like this.
oh no 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 no. I meant like if it was x plus 2 and then x plus 4 squared, for example. Because how do you split that into partial fractions, you know?
What will be numerator? X plus 2. Give me an example.
Okay, so the numerator can be anything, but in the denominator, you would have
Yeah,
like x minus 4, for example,
x x
and
minus 4.
then x plus 8, but the bracket all squared.
Like this. Okay.
Yeah, yeah, like that.
Okay, that is an next question.
Oh, okay,
That is
yeah.
next question. We will solve this question. This is called linear repeated factors. A factor is
Hmm.
linear. Factor is linear, but it is coming two times. So this
Yeah.
is linear repeated,
Hmm.
linear repeated factor, right? This is the
Yeah.
second case. This is the second case. So
Hmm.
we will do it in next question. So we will complete this exercise. There is nothing more than this. There are only two cases in your exercise. One case is when denominator has linear factors like this example.
Hmm.
And
Yeah.
the second case is when denominator has linear and repeated. Some of the factors are repeated.
Okay.
So these are only two cases. So after
It's never
resolving
called.
into partial, yeah, there is no any
Okay.
third case in your book.
Okay.
Otherwise,
Okay.
there are four cases, but in your book there are only two cases.
Hmm.
So after resolving into partial fraction, what is the next step? You apply integration both sides like this, right? Integrate each of the terms. Integrate this, and integrate this. How can we integrate the first part? One. What is the integration of one? It is simply x. What is the integration of this? What
If
is
you
integ?
make the 3 present and then take a third out, it would just be a third log 3x minus 2. Okay.
Okay. Again here,
And then, yeah, minus 2 over 3 log 3x plus 2.
we can express these two terms in single logarithm.
Hmm.
Take 1 over 3 outside. Take one third outside,
Yeah.
and we can express rest of the things in single logarithm using product rule and power rule. So these two can be taken into power, like here.
Hmm.
So it will be 3x plus 2 whole squared.
Hmm. Hmm.
Is it clear?
Yeah. Yeah. Yeah.
Now let's do one more question from the next case, that is linear repeated factors. There is the
Hmm.
second example is about that. Oh, I think we don't need to do these exercises. All of them are similar, and
Yeah. Yeah.
there are only two cases. Oh, I will see if we need to discuss any question from this exercise. So this is particular
Mm-hmm.
case. First of all, whenever you find a question like this, you need to check what is the degree of numerator.
Mm-hmm.
What is the degree of numerator? It is 2. What is the degree of
Yes.
what is the degree of denominator? It
3.
is 3. So we can apply the integration by we can apply the partial fraction method because the degree of denominator is more than the denominator numerator, right? So
Yeah.
we can go directly. Otherwise, if numerator has higher degree, then you need to divide first.
Mm-hmm.
Okay. So in this
Yeah.
case, when we have linear but one factor is repeated, x minus 2 is coming two times. This is repeated. Factors are linear, but
Mm-hmm.
one factor is repeated. So the method is like we will suppose that the fraction is equal to x minus 2, sorry, x minus 2 whole square. This is equal to a upon the first linear factor
Mm-hmm.
plus b upon the second linear factor and plus c upon the linear factor repeated like this.
Oh. Wait, but.
N- Now, if suppose we have a power 4 here, what will be happen?
Mm-hmm.
What will be the our supposition then? If we have power 4 here, then we will suppose it like a upon the first factor plus b upon x minus 2 plus c upon x
Mm-hmm.
minus 2 squared plus d upon x minus 2 cube, and we will add one power in each term plus e upon x
Oh.
minus 2 degree 4 like this, right?
Uh-huh.
Right?
Yeah. Why is that?
Because
Why is that?
we are lucky that we have power 2 here,
Mm-hmm.
so we don't need to extend it to power 3 4, just keeping up
Mm-hmm.
to power 2. This is our first equation. You got that?
Yeah. Okay. So
Okay.
you include.
Now
Okay.
you include two terms
Yeah.
for
Yeah.
this
Okay.
repeated factor. Okay. So what is next? Next is to form the second equation by multiplying the denominator both sides. Multiply the denominator both sides to this equation. So only numerator will be left on the left side and 2x plus 2 will be cancelled. So a will be multiplied with x minus 2 squared. X minus 2 will be cancelled. So b will be multiplied by 2x plus 1 and x minus 2 power 1. Similarly,
Mm-hmm.
x minus 2 squared will be cancelled, and what will be left with c after multiplication? Only 2x plus 1. You got that point?
Yes.
So after making
So that's
equation 2,
okay.
now you need to find a and b. Remember that you can put the value of x, the number of times you have to see how many factors, linear factors you have. If we have two linear
Hmm.
factors, you can put the value of x two times,
Yeah.
right? If we have three
Yeah.
linear factors, then we can put the value of x three times. You have to see how many linear factors are there. So we have two linear factors.
Hmm.
So we can put the value of x to make this equal to 0. What value of x we will put here? Negative 1 over 2.
Uh. Yeah.
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 So we can put x equal to negative 1 over 2, or we can put x equal to 2 here
Just.
in order to make this
Yeah.
factor equal to 0.
Hmm.
So but we can, when we put a value, we will have a cost value of a constant. One value against one substitution, right? But you see here we
Yeah.
have three constants, a, b, and c. How many constants we have?
Yeah. So we're gonna
Three
need
constants.
simultaneous equations. Three.
Yeah, we don't have third value of x to put. So what we will do, the other method is to compare the coefficients of like powers of x both sides.
Oh yeah, yeah.
This we will apply. So first of all, we will put the value for each linear factor. For the first linear factor, we will put x equal to negative 1 over 2, right?
Mhm.
In equation 2. So let's put x equal to negative 1 over 2 in equation number 2.
Sounds good.
So wherever we have x 2x plus 1, this will become 0. Where is 2x plus 1? In the second and third term,
Mhm.
here and here. So
Yeah.
both of these brackets will be 0. So only first term will be left.
Mhm.
So we will write only first term because rest of the terms are zeros.
Yeah.
Just calculate this. I think first term will be 2 and second
What's
term
that?
is 19 over 2 and plus 1.
Mhm.
And this is 5 over 2 squared, 25 over 4. What is the left hand side?
25/2.
So 25 will be cancelled, 2 will be cancelled, so only 2 will be. So what is the value of a we are getting is 2.
Yeah.
Okay, so a is 2. Next value we can put for this linear factor, second linear factor, that is x minus 2. So the
Mhm.
this will become, for which value of x, this will become 0. This will vanish
2.
for x equal to 2. So now we will
Mhm.
put x equal to 2 in equation 2 again.
Yeah.
So when you put x equal to 2, left hand side will be 2 squared minus 19 times 2 plus 1. And from the right hand side, which factor will retain? Which term will retain? Only this third term, because
Oh.
this will become 0. So c times 2x plus 1 will retain
Mhm.
only. First term will be 0, second term will be 0, c times 2x plus 1 will retain. X is 2. We are putting x equal to. So c times
Yeah.
5. Left hand side is 4 8s are 32, 19 into 2, 38 plus 1.
Plus one.
Calculate this. This is 5 times c. So minus
Minus
5,
38.
minus 5,
Minus 6. Plus 1. Just 5. So C.
minus 5.
Yes. So C
So
minus 1.
c is negative 1. So we have obtained two values.
Mhm.
A is 2 and c is minus 1. What about b? How can we obtain B? There is no other value we can put. We can put
Um,
only one value for one linear factor. What about how can we find B now?
um, should we not just pick x as a random number and then substitute a and c into the equation?
Exactly. Yeah. That is also fine. That is also fine. But what about if we have the fourth constant as well? Then,
Oh, I have no idea
for
what you
example,
mean. There's a four.
for, for example, we have power 3 here. Then there will be A, B, C, and D as well.
Oh, yeah.
There should be a general method, right?
Yeah.
You are right. We can put any random number and put A and C, then B will be determined very easily. But what if
Hmm.
there are two more unknowns? Then what we will do? We cannot in that case we cannot put value of x, any random value of x. We are unable to find those two unknowns because there are two unknowns in that case. So what is the general
Hmm.
method? Let me tell you. You should know the general method.
Okay.
Okay. So the general method is you further simplify equation number two, or we can let's pick equation number two from above. Let
Yeah.
me just pick this equation. This is our equation number two. Sorry, uh, this is equation number two. Add to the
Mm.
current page. Let's bring it down. Uh, Here we have this is equation. Now
Yeah.
from this equation, we need to simplify this equation a little bit more. Open this square, a minus b whole squared. What will it be? X square
Eh,
minus 4x plus 4
yeah.
plus b times multiply these two brackets. What will be
Hmm.
the product?
2
2x
squared
squared
minus 4 minus
minus
5x
4x hmm?
minus 6
minus
minus 2.
3x minus 2 plus
Yeah.
c times 2x
Yeah.
plus 1. So we will get a third equation like this. After simplifying the second equation, you get a third equation. Now you compare the coefficient of x squared both sides. This method is general method. Compare coefficients of like powers of x.
Huh.
Like powers of x both sides. This is the method.
Yeah.
So which is the largest power? You can compare the coefficients of x square both sides. You can compare the coefficients of x both sides. You can compare constants both sides. Because highest power is x square, we can start with comparing coefficients of x square. What is the coefficient of x square on the left hand side?
8.
8. What is the coefficient of x square on the right hand side? X square is coming at two places. The coefficient here in this term is what is coefficient?
Was it 4? Was it a 4?
No, no, no. What is coefficient of x square here?
It's a, is it not?
Yeah, it is a. What is the coefficient of x square here in this term?
2b.
So overall, the coefficient is a plus 2b. Okay.
Oh, yeah. I see.
Okay. Similarly, if we need to compare the coefficient of x, what is the coefficient of x on the left hand side? It is minus 19. What is coefficient of x on the right hand side is minus 4a, minus 3b, and plus 2c. These are coefficients of x. What are
I see.
constants on the constant on left hand side is 1 and
Yeah.
constant on the right hand side is 4 times a minus
Minus
2 times
2b
b
and
and
plus c.
plus c. So we have these three relations between A, B,
Yeah,
and C. Which one you like, use it to find the
like
remaining
x squared.
unknowns. Which
Yeah,
one we should use? First one,
x squared. Yeah.
this is equation 4, equation 5, and equation 6. So we can use equation, any one of these equations. I think 4 is
Let's just
simpler.
yeah.
Let's use 4. 8 equals to, what is the value of A we have obtained from the first method? It is 2. A
Okay,
is
it's
2.
two.
So let's put A is the
Oh,
2 and
B is three.
6 equal to 2B. So B is 3.
That's a good method. That's better than better than putting in a random number and seeing how it
Yeah, yeah.
works. Yeah, I
This
see
is
that. I
more
see that.
general method and it will work in every case,
Yeah, yeah, yeah.
eh,
Even with
no
more and
matter how
more.
many. Yeah, yeah.
Mhm.
Even we have more unknowns. So
Okay.
it is better to always apply the general method.
Mm.
So it's because it is applicable for every case, not for this
Yeah,
one
yeah.
only. Okay.
Mm.
So now we have found, obtained all these constants. A is 2, B is 3, and C is negative 1.
Mhm.
What we will
Yeah.
do, we will integrate here. 2, 3, and negative 1. Right? 2, 3, and negative 1. So we have resolved it into partial fractions. This will be 2, sorry, 2, 3, and negative 1.
Mhm.
We need to integrate this now after resolving into partial fractions. Is it clear?
Yeah. Yeah,
Okay,
yeah,
now
yeah.
I am
That's clear.
going, I am solving upwards. I am going upwards now. So what is the integration of this?
Mhm.
You can,
2x plus 1 derivative
yeah,
is 2. So yeah, just learn 2x plus 1.
plus
And
3
so that's going to
times.
be a
What is the
third
integration of?
log x minus 2.
Yeah, exactly. What
A
about the
third
third
log
term?
x minus
This.
2. Oh, wait.
What
You just
about,
keep
what
2.
about, hmm? What about this?
X minus 2 to the power 3 all over 3, right?
No,
Because it's
no, 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 no.
just normal
It,
power, isn't it? Oh,
no,
because it's.
no.
Yeah, 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 yeah.
Because if we take in the numerator, it will
Hmm,
be
hmm.
power negative 2. It will be power negative 2, and you have to make sure that the derivative of the
Yeah,
inner function is present. What is the derivative of inner function?
yeah. Yeah,
What is the
just 1.
derivative of just one? So that's why you can do integral directly. Okay. So
Yeah.
we can
Right.
we can express in this in single logarithm the first two terms
Hmm.
log of 2x plus 1
And then
times x
x
minus
minus 2
2
cube.
cube and plus 1
Hmm.
over x minus 2, 1 over x
Hmm.
minus 2, right? Let's see.
Yeah, plus
So
c.
why plus? Because this
Nice.
negative and this negative will become
Oh,
positive. This is the answer.
hmm, hmm.
If you have any questions
Yeah.
here, you can ask. Otherwise,
No, that's all fine. So before next session, as soon as I get my test, if it's all right, I'll send it to you on WhatsApp, and then maybe have a look over the questions, and then if we can go through them,
yeah, yeah, no
then
problem.
that would. All right.
No problem.
So thank you so much, and I'll
Now
see
you,
you.
I am waiting for the message from your mother. He must ask me that what are you doing?
She won. She won. She
She
knows you
must
haven't.
be worried about your results.
Yeah, I. We'll talk about it Wednesday, huh? All right. I'll see you later.
Okay, see you. Thank you.